Hello, MAT1510 UNISA students. I am Muhammad Armien Hendricks. I'm one of the e-tutors for this particular module for 2021. I've prepared a PowerPoint presentation to assist you with assignment number 4, and specifically the graphical representation of trigonometric functions, the sine, cosine, and tangent functions, in which I will look at the various properties. I hope this will assist you. Thank you. Let's continue. Let's look at the basic trigonometric functions, right? Let's start with that's correct. Let's look at the sine function. If you look at the sine function, you can see, let's put in the sine function there. What is its amplitude? As you can see, the amplitude there is, 1. Okay, the amplitude is 1. And the range there, it's the corresponding y values. It's from -1 to 1. That's how we can write it down, from -1 to 1. We use the interval notation. The period, sine is a periodic function there, so every time it repeats the pattern. See that there, the pattern is repeated 2 pi. Right, so that's the period there is 2 pi. We have another 2 pi, I will get another pattern like that. You see, it increases, then it decreases, and then it increases. So that's a full pattern for the sine. Sine functions, they don't have asymptotes because sine is defined for all values. So there's no asymptotes. The x-intercepts, you can see there are 3 x-intercepts in this period. It's at 0, pi, and 2 pi. Okay, let's look at the next function. That one there is the cosine function. If you look at the cosine function, it also has an amplitude of 1. You can actually see there the coefficient of cosine is 1. So it's 1. Therefore it's 1 there. And then the range is also from -1 to 1. Right? The values you only find the output values from -1 to 1. The period also, that's a cosine pattern. There's the cosine pattern, and it repeats itself every 2 pi. Also no asymptotes, and the intercepts here are but different. The intercepts there are at pi over 2 and 3 pi over 2. Let's look at our third function. That's the tangent function. Now a tangent function there doesn't have an amplitude. Can you see that it goes to infinity and negative? So tangent function does not have an amplitude. No amplitude, but it has a range. The range is from -infinity to infinity. The outputs are any values between -infinity and infinity. As you can see, the period for tangent, this is a tangent pattern. There is a tangent, so it's from 0 to pi, right? So the period there is pi. See? And you can see there it repeats exactly the same pattern there. So in the first 2 quadrants, and then the third and the fourth is a repetition of the first and the second. Tangent, however, has asymptotes because tangent is undefined by pi over 2, and it's undefined by 3 pi over 2. And what are the intercepts? If I look at the intercepts there, the intercepts are there at 0 and pi, and it repeats itself, right? So I only put down for the period, I only put down 0 and pi. For one period, 0 and pi. If you continue, it will be 2 pi, then it will be 4 pi, and then it will be 6 pi, right? Multiples of. So these are the basic functions, and you should be able to draw a sine and a cosine graph just freehand. There's it there, so you should know it has a maximum at 1 and a minimum at -1, a minimum at -1 and a maximum at 1. Tangent has, because it's from infinity, there's no minimum and maximum values because the range is from -infinity to infinity there. And then we need to know sine and cosine has the same period, but tangent repeats itself every pi. Okay, asymptotes, the tangent is the one with asymptotes, but all of them have x-intercepts. In the previous slide, we just looked at the basic functions, sine, cosine, and tangent. What we're going to do next is we're going to look at the various changes, the various transformations that can occur, right? We start off with the change in amplitude and vertical shift, right? So let's start with the sine function. If we look at the sine function here, I have represented the sine function here between the domain from negative 2 pi to 2 pi. As you can see there, there's a sine pattern there, and then we've got repeated on the negative side. If we look at the positive side there, you can see sine is positive in the first quadrant, and it's still positive in the second quadrant, then it's negative in the third quadrant, and positive in the fourth quadrant, and then it repeats itself, right? So this is the basic one. I've put in some negative values for x, and I have some negative values and some positive values. So this is our basic function. Now we're going to transform it. Transform it means we're going to make some changes to it. In this case, the amplitude is 1, and that 1 is actually the coefficient of the sine. That's 1 sine. Although we don't write down the 1, that's 1 sine 1x, so that's 1 sine. If I look at this one here, you can see there's a transformation, there's a change here. This is now a 2 sine. And when I have 2, then 2 as a coefficient there, then the amplitude is 2. So if I look at this one, you can see there's the graph, right? Still the same shape there, but it has now a different amplitude, right? So the amplitude is 2, seems to be stretched vertical stretch there. So there the maximum value was 1, and there the maximum value is 2. Similarly, if I should have had 3 sine x, the amplitude would be 3. We look at the other case where we have negatives there. So in other words, if I have generally a sine x, so the amplitude will be this a, but it always will be a absolute value. And you know the absolute value should give you a positive value then in the end. So the absolute value of a, which would be your amplitude. Let's look at this one. Here we've got a different transformation. I don't have 1 sine x or 2. I've got 1 plus. I'm adding a 1 to that. The amplitude here, it's still a 1 sine. The amplitude is still 1. But now I'm making a shift of 1 there. And if we represent this particular graph 1 plus sine x, it is this purple one, the magenta one that we see there. So you can see that I still maintain the sine pattern, right? It's still positive in the first, positive in the second, negative in the third, negative in the fourth, but now I've shifted it. You see, you can see, look at the, compare it from the yellow, then from the 0 it was shifted 1 up. That was 1, so I shifted 1 up. Everything was shifted 1 up there. Okay, so if we now generalize this b value that I have there, right? B plus sine, this b would be the vertical shift, right? If b is a positive number, then I've moved it 1 up. If b is a negative number, then I've moved it 1 down. In the sine, we'll take 1 where we move it down. So this is the vertical shift up. Let's do it the cosine function, but we're going to do some different changes in amplitude and vertical shifts here. So let's take our basic cosine function. Let's go through it again. As you can see, cosine is positive in the first, negative in the second, negative in the third, and then positive in the fourth, right? So that's the period. The period is 2 pi, right? If I go on the negative side, then I also get positive, negative, negative, positive, right? So there I've got 2 cosine cycles there. There's 1 cycle, right? Again here, this is 1 cos x, so the amplitude is 1. Let's look at this one. Here you can see I've got a negative 2. And if I have a negative 2, it's actually a reflection in the x-axis, right? So in other words, there I started by 1. Here I'm starting with a negative 2. You can see this blue one here. It's a reflection in the x-axis. There is a positive and this one is negative, right? So the yellow one there first decreases. The blue one starts increasing again first. Okay? And here the amplitude is the absolute value of negative 2 is 2. Amplitude is always an absolute value. It's always a positive value. So this is what we have there. So you can see the amplitude is 1. The amplitude is 2 there. But because I had a negative 2, it's a reflection in the x-axis. A positive value becomes a negative value, and a negative value becomes a positive value, and a positive value becomes a negative value. So if we generalize here, if I have a cos x, the amplitude also would be the absolute value of the coefficient there. Let's look at this one. Here I've got a shift, but now I've got negative 1 cos x. And if I do that, you see there's my original, my basic cosine graph there. But now because I say negative 1, I've moved 1, I move it 1 down, so it's 0. Negative 1, I moved, everything is moved 1 down. So I've got this, there's my magenta curve there. Okay. So this is a vertical shift, and we say 1 down. So if I have a negative 1, it's 1 down. If I have a negative 3, it is 3 down. If I have a negative 5, it is 5 down. So everything is shifted. You see that point is 1 down. All the points on the curve is moved 1 down there. So if we generalize now, if I've got b plus cosine, this value here will represent the vertical shift. If it's positive, it goes up. If it's negative, it goes down. And in the next slide there, we'll just look at the tangent function as well, with the same type of changes. Now we're going to look at some of the changes to a tangent. Remember, tangent does not have an amplitude, so we're not going to look at amplitude here. There's the tangent. Let's just go over some of the properties there. You see tangent has asymptote, so it's undefined by pi over 2, 3 pi over 2, and it can continue. It has a period of pi from 0 to pi, so that's a tangent cycle. There's another one, you see. So in 2 pi, I've got 2 cycles, and from 0 to negative 2 pi, so actually there are 4 cycles here. 1, 2, 3, 4, right? So to a tangent, we're going to have the asymptotes there. Let's look at this one here. Remember, this is not an amplitude 2 tan. So let's look at that 2 tangent x. Can you see there? The 0 still remains 0. 2 times 0 is 0. But now you see this y value was a 1. So 2 times 1 will be 2. You see? So at pi over 4, I get a corresponding value of 2. If this was 3 tan x, then by pi over 4, I'll get a 3 there. If this was 5 tan x, and it will be by 5, right? So you can see there the 0 still, 2 times 0 is still 0, but 2 times 1 becomes 2, right? If there was a 3, it will be 3 times 1. So it's still the same pattern there, just you now have it rising a bit faster. Let's take that one away because I want to do the other one. Here I've got 1 plus. And remember, when we add and subtract, we're having a shift. So that's a plus 1, so it's a vertical shift up. And you can see there it was 0, it moved 1 up. There it was 1, it moved 1 up. There it was negative 1, it goes up, etc. Right? So this is what a 1 plus tangent graph. It's a vertical shift upwards. Okay? But nothing happens to the asymptotes. See, there's no change to the asymptotes there. So let's put that 2 tan x back again, so we can compare them. So generally, if I have a plus b tan x, a represents a vertical shift, and b there is not an, just remind you, the tangent function does not have an amplitude. Don't make a mistake and say it has an amplitude of 2. It's just stretching it. Now, let's look at the sine function, but we're going to look at a change in the period here. So if I take my sine function, the basic period there is 2 pi. You see there's a sine, I've got another one on the negative side. So the period there is 2 pi, because if I have a 1x, the period is 2 pi, right? Now if I have a 2x and I represent the 2x, see there's the 2x represented. I've plotted all the points. But in this case, if you can see there, this cycle here only needs pi. You see there's so the period for this blue now is pi, not 2 pi. Where the period for the yellow was 2 pi. For the blue there is. So you can actually see 2x in that 2 pi. I can fit 2 of them in there, right? And here I had 2 yellow ones. I can fit in 4 blue ones from negative infinite 2 pi to 2 pi. So the period, you take your period, you take 2 pi and that coefficient 2 pi divided by 2. If this is 4 pi, it will be 2 pi divided by 4. If this is 5x, it will be 2 pi divided by 5, right? Let's look at the one with a half. You see now, in that curve there I fit it. You can see this is the sine pattern. It has that 2 positive and then 2 negatives. But if I take half, I only have half of the pattern. You see, that's half of the pattern. So from 0 to 2 pi, it only fits in half. So the whole period for this one will be 2 pi on the negative and 2 pi on the positive, which gives me 4 pi. How did we get that? It's 2 pi divided by the coefficient of x. That is half x. 2 pi divided by half is 4 pi. I hope you don't use a calculator here. So let's generalize. If I have sine ax, the period is 2 pi divided by that a. That will always use a positive value there. So 2x, so there'll be 2 pi divided by 2. 3x, 2 pi divided by 3. So that's how we can obtain the period. Let's look at the cosine, and just with a few different changes. There's the cosine pattern, and from negative 2 pi to pi, I've got 2 cycles there. So that's 0 to 2 pi. You can see the basic period there is 2 pi. Now I'm making a change, 2x. So it will be 2 pi divided by that 2, and which is pi. As you can see there, there's the full cycle for cosine. It seems to be shrinking. It's compressed. And for cosine of half x, it's stretched horizontally. So it's 2 pi divided by half is 4 pi. You can see there. On the positive side, I could only fit in half of the curve. That's why that half there. If I look at the blue, on the positive side, I could fit in 2 cycles now. If you have 2x, you get 2 cycles. If you have half within that same space, you'll get half the cycles there. So if we generalize again, cosine of ax is 2 pi divided by the a. That should give you your period. So if I have cos 6x, it will be 2 pi over 6. Now let's see what happens to the tangent function. I'm taking the tangent, and remember that the period for tangent is there's from 0 to pi, there's 1 cycle for tangent. There's another one, and there's another 2 on the negative side. So this is the period from 0 to pi. If I take tan of half x the same way, because the period is pi, so it will be pi over the half, and pi over the half is 2 pi. If you now look at the yellow ones there, can you see there? The yellow there's a full cycle for the yellow. So from 0 to pi, so from 0 to 2 pi I get now. And you can see the asymptotes has changed as well. There the asymptotes were at pi over 2. The new one there will be double that. 2 times pi over 2, it will be at pi. So instead of being at negative pi over 2, it will be now. So this, if I have half x there, I seem to have been stretching it. You see, the yellow one seems to be a stretched version of the tangent curve there. Okay, so if I have tan ax, again, to work out the period for tan, remember we need pi over a, not 2 pi. Pi over a there. Okay, so there I've got my, if I'll just look on the positive side there I've got from 0 to 2 pi there, and then my asymptote there is going to be at pi. The same way, we can work out asymptotes. If we take asymptotes there, remember tangent does not have an amplitude. The asymptote for tangent there would be pi over 2 divided by a half. Okay, and then you can get the new asymptote there, which will be pi. Now we're going to look at some other transformations, and these transformations we refer to them as phase shifts. So if I look at my sine graph, I've got a sine cycle on the positive side and one on the negative side there, right? As you can see, the period there is 2 pi, the amplitude is 1, and the range is from -1 to 1. Okay, so if I have the amplitude is 1, and that's a 1x. I'm not doing anything to the x, right? So in this case, if I take this one, now I'm doing something with the x. I'm changing the sine function now, x minus pi over 2. And if we represent that, we get this yellow curve there. Now just follow what happened to it. You see there's 0. it now moved to pi over 2, right? And each point there, you see that one was at pi over 2, it moved to pi. So when I have a negative, I seem to be moving the graph to the right hand side. You see, the origin was 0, 0, now it moved there. That point moved there. And this horizontal shift we refer to as the phase shift. And in this case, we're moving the graph from, you see, from the blue, it shifted this way. So we're moving it to the right. So if it's negative there, then I'm moving it to the right. Later, if we take a positive, we'll show you it moves to the left. Right. So in the case of the sine, there's no change by the x, so we say there's no phase shift there. Now this is the basic function. But because we've got negative pi over 2, you see, can you see there? I'm indicating that's the shift. It moved to that's going this way. That point moves pi over 2 to the right. Each point is moved pi over 2 to the right. That is moved pi over 2 to the right. That point is moved pi over 2 to the right. All the points are moved pi over 2 to the right. That's the phase shift. So we can see the phase shift there is pi over 2 and it's to the right. When there's a negative, when I subtract, it will be to the right. If I add, it will be to the left there. Okay, and the period there is still, you see, it's still a 1x, so the period is still 2 pi. See, I haven't changed, the coefficient of x hasn't changed, that's 1x. I'm now shifting either to the left or to the right. So generally, if I have sine ax plus b, this a here will affect the period. But to get the phase shift, it's this b value divided by a. So it's b divided by a. In this case, you can see the b value is pi over 2. Let's ignore the negative first. Pi over 2 divided by 1. So the phase shift is pi over 2. But because I have a negative, it's moved to the right. So if b is a negative value, it will go to the right. Let's take the cosine graph now. Okay, again a period of 2 pi. So let's look at this one. Now I'm taking 2x plus pi over 2. And if we represent that, this is the function that we get there. If we can follow there, remember the sine, its y-axis intercept there was at 1. Now it's not at, and then it moved from 0 and 1, now it moved this way. And what is that distance there? If this is from 0 to pi over 2, this unmarked line here, that point there will be pi over 4. So I'm moving this pi over 4. Now how did we get the pi over 4? Okay, so that one doesn't have a shift. This one here, you can see the shift is that little piece. And from there to there is pi over 2. So that piece is obviously pi over 4. Let's show you how we can get that pi over 4. There's two ways we can do it. So phase shift there will be the pi over, see this pi over 2 divided by that 2. Pi over 2 divided by 2 is pi over 4. And because that was a plus, it moved to the left. I could also do it by taking out my common factor. If I take a common factor out of 2, I get pi over 4. So if it's in this form, there's the phase shift, pi over 4. And if it's positive, it's obviously to the left. So generally, if I have ax plus b, you can work out the phase shift as being b over a. But if you take out the common factor there, you make the coefficient of x a 1, then you can just read off the phase shift. And that b over a is the same as this b over a. Again there, if b is positive, you move it to the left. If b is negative, you move it to the right. Let's see whether we can calculate phase shifts using the equation there. I'm taking sine, cosine, and tangent. So the same principle we're going to use. So if I take the sine one here, you see we can't read the phase shift here because it's plus. It will obviously move to the left. But now I have to do a little bit of calculation, or I have to take out a common factor. So this will be that will be 1 over 3. So the phase shift there will be 1 pi. Let's just generally have there. If I want to work out the phase shift, it's the b value divided by the a. And obviously you have to check whether it's positive or negative. So let's look at the first one. As you can see there, the phase shift is pi over 3. And because it's positive, it's to the left. Let's look at the negative one. This is subtracting, so it will be to the left. But this case here, I can actually just read it off, right? I don't have to do a calculation. So in this case here, we don't have to do anything there. There's the phase shift, pi over 4. If it's, I just have x minus that, right? But if it's not, then you have to take out a common factor to get it here. Okay, or you can do the calculation. But this is obviously pi over 4 over 1 is just pi over 4. The same with the tangent. We do exactly the same. Doesn't matter what trigonometric function we have or what function. It's the same principle we use. So the phase shift will be pi over a half. Pi over a half is 2 pi. And because I have a subtraction there, it's shifted to the right there. So this here rule applies to sine, cosine, and tangent. Now next we want to show you how to sketch a sine function with all these transformations there, right? I mean, this particular sine function, you should be able to draw it with your eyes closed, right? So let's just see what that one looks like. So we just draw one period of it, right? And one period will just 0 to 2 pi. I'm not drawing a negative one, I just want to have one period. So we're always going to draw one period of the new function there. Now you can see if I have to take this particular example, there are many things that's happening to that. There I have 2x, then subtract the pi, then it's 3 sine, and then 1 there. So let's look at all the various properties here. Let's start off first of all with the amplitude. The amplitude there is -3. So it's an absolute of -3, which is 3. So the amplitude will be 3, right? But because this is a -3, you see the sine graph there first increases. So if I have a -3, it's going to decrease first, right? But I have an amplitude of 3. So you can see there's an amplitude of 3 spaces. That will be the size of my amplitude there, right? So let's put the amplitude of 3 down in the meantime. Then the next thing I want is the range. Now a range normally would be from -3 to 3, but I'm also shifting it 1 up. So it's -3 plus 1 and 3 plus 1, which gives me -2 to 4. So the graph will be between -2 and 4, right? From -2 to 4. Let's look at the vertical shift. The vertical shift, this A value represents the vertical shift. So the A value is 1 and it's a +1. So it will be 1 up. So there will be a shift. That point there will go 1 up and every point will go 1 up. Okay. So obviously if I have an amplitude of 3, it will go like that. Okay. So that point will go 1 up. The 3 will go 1 up, and all the points will move 1 up. Okay. Now let's look at the period. The period for this one, if I've got a 2x, the period is 2 pi over 2, so the period is pi. See, the period is changing. If it was 1x, the period would be 2 pi. But now I have 2x, so it's 2 pi over 2, which is going to be pi. So this is the period, right? From there to there, or from 0 to pi, or from pi to 2 pi, right? So there you can see there's a period of 2 pi, because each one represents pi over 4. So that's pi over 4 with another pi over 4. So that's pi over 2 plus another pi over 2. That gives me pi. So there's a period of pi. Okay. Then let's look at the phase shift. The phase shift there, because it's negative, it's going to be moving to the right. So it's going to be pi over 2. So it's pi over 2. So the phase shift there. And now let's just see what the phase shift is going to be. So there's a pi over 2. So I'm moving it from there and I'm moving it pi over 2 to the right. So this point will have to go 1 up and then it will have to go 2 to the right, right? So this, it will move 1 up and it will also go 2 to the right. So my new point will have to be here. Okay, now if we draw that graph, right, there's my phase shift there. And I want to have a sine graph, and there's my sine graph. But now because I had -3, I won't go up first, I'll go 3 down. Right? The amplitude is 3. You see, I'm moving 1 vertical shift and then a phase shift. And then I can start drawing my graph. Because it's -3, it goes down 3, and then it comes up 3, and then it goes up 3, and it comes down. So there I've got one period of that particular graph there. Okay, let's just go over that again. This one means that 0 will be moving 1 up. The face, now it goes to the right, and then I can draw my graph, right? I just need to know, because it's -3, I won't go up, I'll go down, and then can get my pattern. And remember we said the range is from -2 to 4. You can see there it goes like that's also my sine pattern there. In the next one, we're going to look at a cosine function with also some changes. Let's look at a cosine one with some different changes there. So the cosine, we should just know a basic cosine. There's a cosine curve, right? So we're just going to orientate ourselves with respect to this curve. So this curve, you can use it as a guiding template there. So you can see there's it has 1 and then 0 and then -1 and 0 and 1, and it has a period of 2 pi. So it goes from 1 to 0 to -1 to 0 to 1. That's the pattern that I'm following. It's positive, then negative, then positive, and then negative. And especially if I've got a 1 there, then it will make that pattern. If I had a negative cos, it will go just it's a bit of reflection in the x-axis. So let's take this graph here. Let's see now. So this here is the face there. This is going to affect the period, right? This affects the amplitude, and this is a vertical shift. So if we look at the vertical shift there is going to be 1, but it's -1, so it's 1 down. This is a normal cosine, it's a +2, so it will still have this pattern there. It won't be a reflection of this pattern. But the amplitude is, so the amplitude is a 2, right? So instead of an amplitude of 1, I'm going to have a graph that goes from 2 to 0, from 0 to -2, back to 0 and up to 2. So that is what this tells me, right? Then I've got, so there's my amplitude is going to be 2. So there I've got an amplitude of 2, just represent any, there's also an amplitude of 2. There I can have an amplitude of 2. Then the period is 2 pi over 1.5. 2 pi over 1.5 is 4 over 3. So I've got a period of 4 over 3. Right? So it's more than pi. So if I represent that, you can see there's a period. Right? It's 4/3. See, I've got my scale here in terms of a third and another third and another third. So there I've got 2/3 and another 2/3. You see, 2/3 and 2/3 makes 4/3. You see, it goes from -2/3 to 2/3. So there I can have a period there. I could also draw it from there to there, right? I can also draw it from there to there. As long as I've got a period of 4 pi over 3. Let's look at the phase shift. The phase shift is pi over 1,5, and pi over 1,5 is 2 over 3. Because it's positive, it's to the left. So this one indicates that point will have to move 2/3 pi to the left. Okay, and I still need to have, what is still missing? That's correct, I still have to look at my vertical shift, right? And my vertical shift there, because it's a -1, it's 1 down. So I'm going to move the graph 1 down. You see, the maximum value would be 2 for this graph. So it will go from 2 down to 1. And this one is 1, it will go. So this one will go 2 down. And if it's 0, it goes 1 down. This one will be a -2, it will go 1 down. That one is 0, it will go 1 down. So everything is going to be moved 1 down, right? So from 2, it will go 1 down. So it will be there. And then I have to shift it, right? I have a vertical shift down. So from 2, it will go down, and then I'll go this way. So my starting point would be here. Okay. So let's look at that graph. And my range is, because I've got an amplitude of 2. It's from -2 to 2, but I'm moving it 1 down. So it's subtract 1 and subtract 1. So between -3 and 1. So my graph should lie between -3 and 1. Remember, 2, we're moving it 1 down, and then we're shifting it, right? A vertical shift down and a horizontal shift to the left. So if I draw my graph, there's a full pattern there. Can you see it? There's a full cosine pattern. I want to see a cosine pattern. Exactly the same pattern. It decreases and then it increases. So there it goes from 1 it has an amplitude of 2, and then another see there it goes down 2, then it goes 2 up, and then 2 up again there, right? And there I've represented this particular graph there, right? This is a positive 2, so it's still a positive cosine shape, right? It was negative 2, it will be a reflection of this in the x-axis there. Now let's look at the tangent one. Okay, so there I've got my basic tangent curve. You see there's a period of pi. I have an asymptote at pi over 2. I just have this as my guiding, so I know this is what the tangent curve should look like, right? If I want to have one period of a new one, I should have a shape like that. A single asymptote, and I need to have it increasing, and then that one is also increasing, right? And then here I have a corresponding point, that's pi over 4 goes with 1, and negative 3/4 pi will also go with negative 1 there. Let's see what is the transformation that we want. We want negative 1. This is a vertical shift. This is a 1 tangent, but now I've got half x plus pi over 4. Okay, and this pi over 4 will give me my, will tell me what my, that's right, my phase, my horizontal shift. Because it's positive, it's going to be moved to the left. This half will affect the period. The period is pi, so the half will affect that pi value there. So let's see. And tangent, we know it doesn't have amplitude, but it has a range. It goes from negative infinity to infinity. From negative infinity to infinity. So let's see there. We've got a vertical shift. It's going to be 1 down. So that point will have to move 1 down. Okay. And then let's get the period, right? The period here, because there's a half x, it will be pi divided by 0.5, which is 2 pi, right? So I'll have a tangent graph 2 pi. See, from there to there is 2 pi, or even from there, you see there I'm just going a quarter back, so I go a quarter this way. From that point to that point is 2 pi. From this point to that point is 2 pi. From this point to that point is 2 pi, right? From this point to that point is 2 pi. From that point to the, see, they can get many 2 pi's in there, right? But so this is to show you that is the period that we're going to have there. Now let's look at the phase. The phase we can immediately see is pi over 4. It's pi over 4 over 1, pi over 4 over 1, which is pi over 4. Because it's positive, it's going to be moved to the left, right? So in other words, that point will be moving down, and then it will be moving to the left, right? So it will go down 1, and it will move pi over 4 to the left. So my starting point is going to be there, which corresponds with that point. So I'm going to have either represent my graph, but what do we also need for tangent? That's correct, we need an asymptote. So let's not forget the asymptote. The asymptote is usually at pi over 2. But because I've got half x, I divided by a half. So this will be the asymptote. But I'm also, asymptote there is a vertical line, so I'm doing a shift. But I must shift it pi over 4. That means I must subtract pi over 4 from it. So if I take this is going to be 2 pi minus a quarter pi, which gives me 3/4 pi. So my asymptote, as you can see, there's the asymptote at 3/4. There I've got the asymptote at 3/4 pi. And once you have the asymptote, remember we said that point moves 1 down and quarter pi to the left, and there's my graph like that, right? And then once I have this pattern, I can just complete the pattern there, right? You can even count 1, 2, 3, 4, 1, 2, 3, 4. You need, so that point there will correspond with that point. You can see this is negative a quarter, and that is positive 1 3/4. 1 3/4 and a quarter gives me 2 pi, right? So there's my asymptote. So my asymptote has moved. So instead of having the asymptote at pi over 2, I now have the asymptote at 3/4. This is how I obtained it. I first take pi over 2 divided by a half, but I must subtract pi over 4 from it. So I subtract pi over 4 from it, and then that gives me 3/4 pi. And there I've got my tangent curve there. You see, we normally would always require you to draw one period of the graph, right? To show one period of it. So you always try to get the same shape. You see that shape? So when you draw a tangent, try rather to draw it like that, right? Don't draw it from there to there and put another piece on the other side. It's more complicated. You just draw, that's the starting. So it moves one down, it says one down, and then it has a shift to the left, and then I can draw it there. So then I can just, once I know where this point is, I just need to get that increasing. So it increases from there to infinity. And this one here, you can see this point here, it will also have to go, okay, because there's a lot of changes taking place here. So I've got that point, and once you have this, we must just have a similar one on the other side there. Now, next we want to do the opposite. And here we actually give you a graph of a function, and we want to find the equation, right? And this is the standard form of the equation there. A plus B sine cx plus d, where this is the vertical change. This is the amplitude. This will affect the period, and the d and the c will give you your phase. And whether this is positive or negative tells you there, okay? So if I look at, so if they give you, this is we want to find the equation of this yellow one. But because it's a sine, I know this is the basic sine. So I can follow what happened to this sine. You see, it started here and then it increased. So now it's moving from there to there. You see, from that point it moved 2 up. Right? It just moved 2 up. It didn't go left or right. It just went straight there. It's on the y-axis, and it's again on the y-axis. So this value here, I know has to be a 2. It has to be a plus 2. Okay, and it hasn't, this point hasn't moved, the graph hasn't shifted left or right. Right? So in other words, we have a phase shift of 0 there. So we'll show you that you're going to have a phase shift of 0. So let's look at that. So I can see there, and I can see my amplitude. There's the amplitude from 2 to 4. The amplitude is, from 2 to 6, the amplitude is 4. Right? Even from 2 to negative 2, the amplitude is still 4. Or what you can do, 2 plus 6 is 8. 8 divided by 2 is 4. Right? You see that distance is 2, that distance is 6. So the total distance is 8. 8 divided by 2 will give you my amplitude. Or you can just see it from the graph. The amplitude there is 4. Okay, the amplitude is 4. So let's write down there. The amplitude is 4. And this is a increasing one, so that will still be a positive 4. It's still the same shape. It is increasing. So from the starting, it increases. From the initial point, it increases. Okay. And now we see this has a vertical shift. It moved from 0 to 2. So there's a vertical shift of 2. So in other words, we've got 2 up. In other words, this A value must be 2. So already I have an A and a B value there. Now we need to get the period. And we can see this is the P. There's a full sine pattern from there to there. And from that to that is exactly pi. See, there's a one period of this curve there. There's one cycle, there's another cycle. So there's actually 4 cycles here. 2 on the positive side and 2 on the negative side. So the period is pi. And if the period is pi, it means that this C value has to be, that's correct, it needs to be just a 1. How can we get that? 2 pi over the pi. You see? 2 pi over the actual period there, this is the basic period. 2 pi over the actual period is pi. 2 pi over pi is 2. Therefore, the C value is going to be 2. Now, there's no phase shift. Right? The phase shift is 0. You see, normally what you can do, you can see there's no phase shift. So the phase shift is 0. And then the C value, we just worked it out as 2. So 0 times 2 is 0. Or you can just see it didn't move left or right. Right? So the phase, that D value needs to be a 0. So if we put that, all the values in there, this is my A value, which is 4. This is my amplitude, which is, my A value, which is 2, my vertical shift. My amplitude is 4, and my period gave me that 2, and I put a D there. So you don't have to write down plus 0. So this is the graph, 2 plus 4 sine of x, right? We could also I could also have a different one. I can also have an identity for that. If I use the -4, you see, I can also look at the graph from there. See, I can also look at this part of the graph. If I focus on this part, I'll be able to get 2, -4, 2x plus pi. Okay. So you can either give the answer like this, or you can have it like that. You know, if you add 3, it's just continuing with the cycle there. Now let's look at the example with cosine. You see, this is we want to find the equation of this particular function that we have here. Okay, it's drawn from -2 pi to 2 pi. And now, because it's a cosine, just draw in your cosine there, just a dotted line there. So I've inserted, I won't give you this one. I'm just putting this blue one to guide me. So I can see that starting point was at 1. Now the starting point is not at 1 anymore. Do you follow? Can you see there? That starting point is now up there. So this point has moved up, right? How much did it move up? From 1, it moved up there, and then it goes to the left, right? So in other words, I can see that because, and what is the amplitude there? The amplitude is, you can see the amplitude, there's 2 spaces, the amplitude is 2. So in other words, if I have the amplitude of 2, this graph would have a y-intercept of 2, but it moved up. So it moved 1 up. Okay, there's the amplitude. You can sort out the amplitude first. The amplitude is 2. No doubt about the amplitude, right? And now I'm having a vertical shift. So the amplitude is 2. And it's still the same shape that I have there. So I can take a positive b there. Okay, and you can see this graph will then move from the 2, it move up. So it moved 1 up. You see, the graph should have just been up to 2, but now it goes higher, it goes up to 3. So it has a vertical shift of 1. So that's going to be a 1, and this is going to be a 2. Let's look at the period. And you can see the period is there from this one minimum to the other minimum, or from the one maximum to the other maximum. You can look anywhere, right? You can even look from that point to that, but look at values that are easy to read off. This is from 1/3 pi up to 4/3 pi, right? So from 1/3 to 4/3, the period will just be pi. So there I've got a period of pi there, right? From that point to that point, you can even check it from that point to that point, any 2 points there. From this point to that point, but it's a bit awkward to read that one off. So let's take it from this point to this point. Okay? So that will give me my full period. You can see there I've got a full period there. So the period there is pi. So you can see that's 2 pi over pi. That will give me my c value. Remember, c is 2 pi over the period, or the period is 2 pi divided by the c, right? Period is 2 pi, so to get c, it's going to be 2 pi divided by the period. So c will be 2 pi. The actual period is pi, and 2 pi over pi will be 2. So that c value is 2. Okay. The only thing now is, instead of cutting in the y-axis, it's now moved to the, you can see it moved to the left. And if I move to the left, I'm going to add. And how much have I moved to the left? If that is 0 and this is a 1/3 pi, it's moving right in the middle of that, which is pi over 6. So I've got a phase shift of pi over 6. See how I got the pi over 6? That's a 1/3 pi in the middle. It's a 6/1/6 pi over 6 there. So the phase shift is right. So if I take the phase shift we see is pi over 6. And to get back the d value, it's pi over 6 times your c value, pi over 6, which is 2/3. So my d value is 2/3, right? To get the d value, remember the formula for the phase shift was d over c. Phase is d over c. So if I want d, it's going to be phase times c. Phase times c, which is pi over 3. And now I can just fill my values in. A value, we saw the a value is 1. And the amplitude is a positive 2 cos, and the period is a 2, the c is a 2, so that's 2x, and then my d value, we just worked out the d value, which is pi over 3. And there we found the equation for this function fx. Now let's look at our last example. Here we've got a tangent. So the yellow is given. So to assist you, because it's a tangent, I suggest we draw in the little tangent curve there so we can follow. So you can see that it starts at 0 and 0, then it increases, right? It has an asymptote at pi over 2, and then there again it goes from pi over 2 up to pi, and then it's increasing. So there's my tangent curve there. Okay, you can see this one starts at 0, 0, and the corresponding point is here. So it doesn't start at 0, 0, it starts at quarter pi and negative 2. So that means it moved 2 down, and then it had a shift to the right. So I know already my A value will be with a vertical shift, and my D value will be my phase shift that I get there. Okay, so let's we can use our phase shift to get our D. So let's look at this here. Tangent function doesn't have an amplitude, but I can look at the vertical shift. It's moved 2 down. Because it's down, it will be negative 2. The asymptote, you can see we can read off the asymptotes. The one asymptote is there, that's steps over quarter. So that's 1 1/4 or 5 over 4. And this one is on the negative side. That's a quarter and another quarter and another quarter. So it's 3/4, negative 3/4, right? And if I have my two asymptotes, I can use it to find my period, right? From the one asymptote to the other asymptote, that's a very easy way to find the period. From an asymptote to an asymptote, that clearly indicates your period there, right? You can see there. From there, if I had my other asymptote from pi over 2 to 3 over pi 2, it will also be a pi. So in this case, it's from this asymptote, which is negative 3/4 pi, up to 1 1/4. So 3/4 and 1 1/4 gives me 2 pi. Okay. And once I have my asymptote, I can use that asymptote, my period, to get my C value. Okay. So my C value there will be pi. Tangent's period is pi. And the actual period for this new tangent graph, for this yellow one, is 2 pi. Pi over 2 pi is 0.5. So C already I know is 0.5. So I already got my A and my C. Then we can see the phase. The graph is moved to the right. How much to the right? That's a quarter, right? So it's a shift there of a quarter. So the phase shift is a quarter. Now you know to get the phase is D over C. So to get D, it's the phase times C. So to work out the D, it's the phase times C. Phase is, we can read off the phase, pi over 4. The C value we worked out, which is 0.5. And pi over 4 times 0.5 is pi over 8. Now to get the B value, we'll do it by substituting. Now see, I can choose any points. There's many points. I can substitute that point or that point or that point or that point or that point. There's many points I could use. I cannot use that point because I don't know the exact value. The easiest point here with the coordinates is, if one of the coordinates is 0, this one is easy there. That's 3/4 with a 0. I could have taken this one also, a quarter with negative 2, but it just, maybe I'm always choose the easier one. If one of your coordinates is a 0, look for a y-intercept or an x-intercept. So I'm taking, but you could have used any of the coordinates there. I'm taking 3/4 pi. So A I already know is a negative 2, B is missing. The C value is 0.5, and my X value I'm now using is 3/4 pi minus, and my D value I worked out, which is 1/8 pi or pi over 8. If I do that little bit of arithmetic, I end up with pi over 4. Tangent of pi over 4 is 1. So B times 1 is 1. I take over the 2. Therefore, B is equal to 2. That's how I work out my B value. Remember, this B value is not a amplitude. So this is how you can work out the B value after you've calculated the A, C, and D, substituting one point. That will assist you in getting your B value. Sometimes it's easy to read it off, but in this case it wasn't that obvious that the B value would be a 2. So there's my equation now. A is my negative 2, B is a 2, okay, there I just worked out B. My C is 0.5, and my D value is pi over 8. Remember, the d value is not the phase. The phase is d over c. So you can't put the phase value in there, right? The phase value is pi over 4. And that is how we can find an equation of a tangent graph. I hope this helps you. You can always stop the video and pause. If you do something, ask yourself first, what's the asymptote, and then you see, right? You can click for the next step there. Just by pausing the video, you can pause it at any particular point. I will also prepare another video to show you how you can draw cosecant and secant and cotangent curves. Thank you. I hope this helped. Hi students, I have a YouTube channel called Maths with Armien, where I'll post a lot of my videos. I also have videos on grade 12 topics. Please subscribe to my channel. If you do that, you'll get notice of any new videos. And if you did like my video, you can just indicate that you like it. But I really would request that you subscribe. Thank you very much.